believe we left off here, okay, with example 3, where we wanted to evaluate these different common logs and natural logs. Okay, so we have to use some of our rules here. So this first one, if I don't see a base for my log, what's the base? 10, right? So this is saying 10 to the log base 10 of 22. How would I do that? Yep, we're not using a calculator. We're not going to divide by 10. So one of our properties that we talked about was a to the log base a of x equals x. So if I've got an exponential raised to a log with the same base, those essentially cancel out. Okay, and remember, I told you I'll be able to give you a much more mathematical reason once we do the next section. Okay, but for now, we're just saying that if I've got an exponential raised to the log base of that same base, those cancel out. Okay, so that means if I've got 10 to the log base 10 of 22, that's just going to be equal to 22, whatever's on the inside of the log there.
That means the next one's just 5.
That means the next one's just 5. Log base e of e to the 5th is just 5. Okay? And again, once we do the next section, I'll be able to give you a better reason of why that happens.
Heck yeah.
Okay? And C, I've got log base e of 1 over e to the 2.5.
What is this? I'm just talking about.
My brain don't
You
work.
did. Yeah, why? So Brady's right. It's negative 2.5. Why is it negative 2.5?
Because Brady.
I don't think he just guessed the right answer.
Because if you do a negative power, it switches the numerator and denominator.
Right. So 1 over e to the 2.5 would be the same as e to the negative 2.5.
Oh yeah.
Right?
Idiot.
Right? We said we can move terms between the numerator and denominator by changing the sign on the exponent. So this would be the same as log base e of e to the negative 2.5 power. So log base e of e essentially cancels out. We just get negative 2.5. Okay. How about something like this, where we've got a log of a log of a log? How would I do something like this? We do. It's not 8.
Well, it's 2.
We're not just going to guess random numbers. We want to start furthest inside we can. So I want to evaluate this first. What's the log base 2 of 8? 3, right? So we're saying 2 to the 3rd power equals 8. So log base 2 of 8 is equal to 3.
Wait, can you explain that?
Yeah, so this part right here, log base 2 of 8, we're saying 2 to what power equals 8?
Oh, okay, to the power.
Yeah, so 2 to the 3rd power equals 8. So log base 2 of 8 is equal to 3. So I can rewrite this as log base 4 of log base 3 of 3. Right? We're saying that's equal to 3. Now we can evaluate the next part. What's log base 3 of 3?
0. No. Yeah, it's got to be 0.
So we're saying log base 3 of 3. So 3 to what power equals 3?
Is it 4?
I think it's 1. I wrote the answer.
Oh, no, it's 0.
3 to what power equals 3? 1. So this is just equal to 1. So now I can rewrite this as log base 4 of 1. So 4 to what power equals 1? Anything to the 0 power equals 1. So all this equals 0. Log base 4 of log base 3 of log base 2 of 8 is equal to 0.
Why does log base 2 of 8 equal 3?
Because what we're saying is this is the exponent, right? So we're saying 2 to what power equals 8? 2 to the third power equals 8.
You can just substitute it.
Yeah, so log base 2 of 8 is this with what it's equal to, 3.
Pretty epic.
Okay, you okay with that one?
Yeah.
How about this one? 2. Log base 2 square root of 2 of 8.
There's too many twos.
The answer is not. No. So,
One of us is 100 eventually.
so what we're saying, 2 square root of 2 to what power equals 8? Okay, this one is maybe a little bit more difficult to visualize.
Oh.
3.5.
Is that an idea, Ho?
I think.
Okay, what's your idea?
No, I don't know.
6. 3.5.
So, I can rewrite 2 square root of 2 by 1.
What if you do 1.5?
Backwards. Yeah. Okay? 2 square root of 2, I can rewrite as a single square root. Okay, this one is a little bit trickier. So I could rewrite this as the square root of 4 times the square root of 2, which is square root of 8.
8. Yeah.
2 square root of 2 is the same as the square root of 8. Okay? So now what we're saying is,
How can you like recognize that?
You look at it and you go, that comes up.
Thanks.
like I said, this one was harder to recognize.
Can't you just put it in the calculator and solve?
That's what I did.
You know what I'm saying?
Yes.
So like 2 square root of 2 equals and then raise it to 2. And then that's going to be what's underneath the radical.
So we're saying the square root of 8 to what power equals 8? So yes, I am going to show you how to do this on the calculator. But I want us to understand first what we're actually doing. Okay? So this one, yes, was tricky to recognize that we can turn this into the square root of 8. Okay, that was tricky to recognize. Okay? How about on our last example here? Log base square root of 3 equals 27. What would I have to raise the square root of 3 to get 27? 5. Well, square root of 3 times square root of 3 5 times. Well, square root of... So this would be the same as the square root of 3 to the 5th, right? And 3 to the 5th is 2. Wait, 3 to the 5th, 243.
You have to put 3 underneath the radical of 2. So it's like 3 seconds.
Shows the.
The answer is 3 halves. I'm fully guaranteed.
So square root of 3 to what power equals 27? That's what we're trying to come up with. Square root of 3 to the third power?
Would it be 4?
We know 3 to the third power is 27.
Yeah, would it be 4?
So I could change the square root of 3 into 3 to the 1/2 power, right? The square root and a 1/2 power are the same thing.
I am not a fan.
It kind of feels like you're just making things up. It just works out for some reason. Like, oh, if I do this, this will happen. Oh,
I'm
wow, I
trying
didn't
to.
expect that to happen.
This part is just kind of understanding how exponents work. So there is a little bit of guessing and checking. I could rewrite 27 as 3 to the third. So how can I get from 1/2 to 3?
2.5.
I can raise this to the 6th power. Because 1/2 times 6 is 3.
It's easier to plug it into the calculator.
Yeah.
On the test, we're gonna have to do it like this.
We actually do that all the time.
Okay, so the square root of 3 to the 6th power equals 27. Okay? And yes, this is tricky, it's complicated to try to figure out what I would have to raise both sides to. Okay, but this is the idea, this is how logs work. We're saying this to what power equals this. Okay? Questions on that? All right, then let's take a look at solving some basic equations. Okay, so on these ones, I don't think the unit circle is going to help you on these.
I was referring to it. You're just making stuff up.
So for all of these, okay, we're just trying to say, well, this number to what power equals this. Okay, yeah, this is a pretty straightforward one, right? 3 to the 2nd power equals 9. So here, x would equal 2. All right, here we're saying 4 to what power equals 1 over 4? That would be -1. Okay, so these are the types of equations that I would expect you to be able to do without a calculator. Okay. How about C? The x is in a different spot. How'd you get 8? Right. I can just rewrite this as an exponential. And say 2 to the 3rd power is equal to x, which is just 8. Okay. So how about similar idea for D? To get x, I'm going to
Read it the -4.
Yeah, I'm going to rewrite this as an exponential. 3 to the -4th equals x. What's 3 to the -4th? What's 3 to the 4th? 81. So it's 1 over 81. How about this? 2 to what power equals 2 radical 2? So we talked about 2 radical 2 is the same as, if I wanted to just rewrite that as a radical
8.
it's the same as a radical 8. Right? That's the example we did backwards up here. Right? So this would actually be the same as log base 2 of the square root of 8 equals x. Yeah, so we're saying 2 to what power equals the square root of 8?
Something with the 2. Oh, wait. 2.
2 to the 2nd power is 4.
It's got to be 1/3
Is it 3 over 2?
or 2/3.
So the square root of 8, okay, I could rewrite 8 as 2 to the 3rd power, right? Sure. So we're saying 2 to what power equals the square root of 2 to the 3rd? Well, if I've got the square root of 2 to the 3rd, that's the same as 2 to the 3 over 2 power.
What?
Wait, sorry, 1/3.
3.
Why?
So we end up with x equals 3/2.
Wait, can we run through how that works exactly? Again, I'm like kind of lost. Remember when I took this class and I didn't regret it?
You only 10 years to stare at the wall.
No, he's doing
Okay.
I think we're gonna need to spend
Where are you lost?
Explain
all of it.
about
all of
You lost on A?
So this whole page number 2
No.
and 3.
A, B, C, I got fine. D was, I, and then E, you just kind of you just left.
yeah, you just kind of lost.
So, are we okay with, I mean, what this means? 2 to what power equals 2 squared
Oh
root
yeah,
2?
I got these 7 down. But
Okay.
am I just gonna have to memorize the 2 radical 2 8? Because I feel like that's a reoccurring.
It has shown up twice, hasn't it?
Is there another example that you can give us that's not correct? So we can
One
use it
radical
like we
one.
don't know.
Sure. How about
1 radical.
log base 3 of 3 radical 3? How about that?
That really
Well, how would we do that?
give me the right.
1. 3 to the first power equals 3 radical 3.
Well, like,
1/3.
So how could I rewrite this as a single radical? 27, right? Because I could rewrite 3.
3 halves.
I could rewrite 3 as the square root of 9, right? So I could rewrite this as square root of 9 times the square root of 3, which would be the square root of 27. So I could say log base 3 of the square root of 27 equals what?
The answer is 3 halves.
Yeah, because I can rewrite 27 as 3 to the third power.
If you do log base 4 and then 4 radical 4, is it going to be 3 halves again? If you do log base 5, 5 radical 5, it's going to be 3 halves.
Yes.
it's always 3 times?
So what you're
So
trying
no
to so if
matter
I
what,
see
it's
that,
right, 3
If
halves.
it's that exact pattern,
if I ever see just log base anything, I'll just write 3 halves.
so if it's log base A of A radical A,
It's 3 halves.
yes.
I'm a math genius. I should say
Please make 3 halves the answer to everything.
Okay, so yeah, if we're following that pattern,
If we ever have a multiple choice test, D should always be.
Please.
always 3 halves
Yeah.
for D.
Because every question we're like,
Oh,
3
the
halves.
3 halves.
Wait, so is this next one 3 halves?
Yeah.
I was
So this next one, I've got a whole equation inside of here. Like it's not an equation, it's still an expression.
You have to.
So how would I solve something like this?
Exactly.
Eventually, yes, but I want to start by rewriting this as an exponential. Right. So I'm gonna do this over here. So 3 to the 0 equals what's 3 to the 0?
1.
1 equals x squared minus x minus 5. Then we move the 1 over. Right? Get everything on one side equal to 0. So x squared minus x minus 6. Then this will factor, right? Into -3 and +2. So we get 3 and then -2. Now, with logs, and we'll get into this a lot more in 2 sections, but I have to check for extraneous solutions. Okay, so I do have to plug both of these values back in, okay, and make sure that I get a positive number. So if I plug 3 in, I get 9 minus 3 would be 6. 6 minus 5 is 1. We're good. As long as we get a positive value, that's an acceptable answer. If I plug in -2, I'm going to get +4
So this one's +2.
plus 2 is 6, minus 5 is 1. So we're good. Both of those are acceptable answers.
Right on. So we stop there.
Please.
So are we okay with solving these basic equations? I know E was a little bit of a struggle. Are we okay on the rest of them? Yes.
I'll say about like 60%. So like still passing, but
Yeah. I'd agree in about 16%.
correct.
Good.
Correct.
Are you good, Mr. Fetch?
Five.
So the last part here,
Oh,
okay, is revisiting compound interest.
Oh yeah.
Okay, so
Let's do it.
what, I guess I'll just rewrite it up here. So our compound interest formula was this. Okay. Our final amount equals the principal amount times 1 plus the rate over the number of times compounded per year raised to the number of times per year times the number of years.
Really?
Okay. So we also had our compounded continuously formula. Right? PERT, principal times E raised to the rate times time power. So here in A, it says we're compounding continuously. So I'm going to use my PERT formula. And it says I invest $10,000 at a rate of 10%. So let's see, my principal amount is 10,000 times E raised to the 10%. So my rate as a decimal would be 0.10 times time. Okay, and it says how long. So I'm gonna solve for time. And if it's asking how long, my answer is going to be an amount of time. Does it take for the investment to reach $120,000? So what I'm saying is I want my final amount to be $120,000. Here's how much I'm starting with. Here's the rate. Figure out how long it's going to take. So I want to solve this equation for t. Okay, well, to do that, we first want to get the exponential by itself. So to do that, I'm going to divide both sides by 10,000. So 120,000 divided by 10,000 is going to be 12. Okay. Now, I want to rewrite this as a log. Okay, that's how I'm going to get t by itself. I'm going to rewrite this as a log. So it may help, okay, if you flip this around, okay, so that you can see the lazy 7. So we're saying log base e of 12 equals 0.10t. So log base e is the same as natural log, right? So log base e of 12 equals 0.10t. Then to get t by itself, I can just divide both sides by 0.10. And I can put this in the calculator. Right? There's a special natural log button on the calculator. So what is the natural log of 12 divided by 0.1? Is that what everybody get? 24.85. So for our investment of $10,000 to reach $120,000, it's going to take almost 25 years. For B, okay, how long would it take to double your money if you invest at a rate of 3.7% compounded continuously? Okay, so let's plug this information into our formula. So we're using PERT again, right, because we're compounding continuously. So A equals PE to the RT power. So it's saying I start with P dollars, right? We don't know how much we actually have. So P times E, and then my rate is 3.7%, so that'll be 0.037. 0.037 times T. Well, it's asking how long it's going to take to double my money. So if I'm starting with P, how would I express double that? 2P. Right? Okay, well, I want to get the exponential by itself. So I'm going to divide both sides by P. Okay, well, when I do that, the P's just cancel out on both sides. Right? And I end up with 2 equals e to the 0.037 t power. Okay, so just like we did for the last example, okay, if we want to see the lazy 7 a little bit better, we can flip this around. So then I'm going to say log base E of 2 equals 0.037t. Divide both sides by 0.037. So what's the natural log of 2 divided by 0.037? Say it again. 0.73.
Wait, don't erase that. 1 moment.
All right, so on the bottom of your note sheet there are 6 problems at the end. Okay, so we did 10 to 48 even instead of 9 to 49 odd.
You'll
so
make
your homework is just those last 6 problems on the bottom of your note sheet.
you will